Good morning, everyone. I'm Samprit Chakraborty. Today, I'm going to discuss a calculus problem with you. This problem came in a past year in a Putnam mathematics competition. So let's start. Question. Suppose you have a function f from 0, 1 to real, which is differentiable on open 0, 1. Okay. Such that there exists a comma b belongs to open 0, 1 such that integral 0 to a fx dx, this is equal to 0, and integral b to 1 fx dx, this is equal to 0. And also it is provided mod of f dash x is less than equal to m for all x belongs to open 0, 1. Now you have to prove that this integral over 0 to 1 fx dx whole modulus, this is less than equal to 1 minus a plus b by 4 times m. So what the component we have in this problem? We have that f is a differentiable function in open 0, 1. Integral 0 to a fx dx is 0 and integral b to 1 fx dx is 0. And mod of f dash x has an upper bound. And we have to prove the given identity, the given result, to prove the given result. Okay, fine. So let's try the problem. Let's see. Okay. So at first, let's focus on 0 to 1 fx dx. Now first focus on integral 0 to a fx dx equal to 0. First focus here. Now what we already have that integral 0 to a fx dx is 0. Now we want to make some connection with 0 to 1 fx dx. So let's do something. Let's change the upper limit and lower limit to 0 to a. So the lower limit is 0. We will do some transformation. So the upper limit will be a. Let's see. So what I'll do here, we'll do, let's say consider x equal to t by a. We are allowed to make such transformation. So your upper limit will be integral. So the overall integral will be 0 to a f of t by a times, and dx will be 1 by a times dt. So this will be dt by a. Okay. Now your a and b belongs to open 0, 1. So you just take a outside of that modulus. So what you have integral 0 to a f of t by a dt times 1 by a. First keep it here. Now we'll do some trick here. Now you already have that 0 to a fx dx is 0, right? So let's this is a very important trick, and this is the Magna Carta step in this problem. 0 to a f of t by a dt minus 0 to a f t dt. This is 1 by a. Why we can write this? We can write this because integral 0 to a f dt is 0. So if you subtract 0 from something, it doesn't matter, right? So this will be minus f t dt times 1 by a. Now here we'll apply Lagrange theorem, LMVT, Lagrange mean value theorem. So by LMVT, there exists some Ct belongs to t by a comma t, or as a belongs to open 0 comma 1, we'll say t comma t by a, such that f dash ct will be, f dash ct will be f of t by a minus ft by t by a minus t. So by LMVT, so this will be 0 to a f dash ct into t times 1 by a minus 1 dt times 1 by a. This is by LMVT. Okay, fine. Now we'll apply two equality here. One is the mod of integral will be less than equal to integral times integral over mod. The integral take the modulus inside the integral. So let's apply that. Mod of f dash ct into t into 1 by a minus 1 dt. Now you already know that mod of fx is less than equal to m for all x belongs to open 0 comma 1, right? So this will be less than equal to m times 0 to a t times 1 by a minus 1 dt as mod f dash x less than equal to m for all x belongs to 0 comma 1. Okay, so this will be equal to m times 1 by a minus 1 t square by 2, and if you get a square by 2 actually. So this will be nothing but m into 1 by a minus 2. So let's call this 1. Now we'll apply the same result, we'll apply the same algorithm using that integral b to 1 fx dx is 0. Now here we'll change the lower part, the lower limit to b and the upper limit to a. Let's see. So now we have integral 0, we'll focus on integral 0 to 1 fx dx. Okay, fine. So we'll do some linear transformation. So such that the upper limit will be 1 and the lower limit will be 0. Let's see. So let's consider t equal to 1 minus bx plus b. Now you can ask me that why I am going to use this linear transformation, why not others? Okay, let t equal to cx plus d. When x equal to 0, I want the lower limit to be b, right? So when x equal to 0, I want t equal to b. So b equal to d. And when x equal to 1, I want the upper limit to be 1. So t to be 1. So 1 equal to x plus d equal to b. So x equal to 1 minus d, which is equal to 1 minus b. So that's why my t will be 1 minus bx plus b. This is my transformation. So this becomes integral b to 1 f of t minus b by 1 minus b dt by 1 minus b. Fine. Okay. Now, what we'll do it similarly by previous one. we'll do 1 by 1 minus b mod of integral b to 1 f of t minus b by 1 minus b dt. Now similarly we'll have b to 1 fx dx equals 0. So we'll subtract that. So as that is 0, will not be any use. The resultant thing will be same. So because since, let me write, since okay. Now similarly like previous one, we'll write this in this way, integral b to 1 f of t minus b by 1 minus b minus ft dt. Okay. Now similarly by LMVT, we'll find some, let's say dt between this t minus b by 1 minus b comma t, or if t minus b by 1 minus b less than t, we'll write t comma t minus b by 1 minus b, doesn't matter. So this will be similarly 1 by 1 minus b 1 some f dash, let's say dt, times t minus b by 1 minus b minus t dt. Okay, this is by LMVT. Okay, now take the modulus inside. This will be less than equal to 1 by 1 minus b integral b to 1 mod of f dash dt into 1 minus t by 1 minus b dt. This will be less than equal to similarly m by 1 minus b whole square integral b to 1 1 minus t dt, which will be mb by 2. Okay, fine. Now from 1 we have that integral over mod of integral over 0 to 1 fx dx that is less than equal to m times 1 minus a by 2. And from 2 we get that mod of integral over 0 to 1 fx dx that is less than equal to mb by 2. Now we'll add this 2. So we'll have, so adding 1 plus 2 we get that twice mod of 0 to 1 fx dx, this is less than equal to m times 1 minus a plus b by 2. So we have that mod of integral over 0 to 1 fx dx less than equal to m times 1 minus a plus b by 4. And we are done. So yeah, congrats, we are done. That's all. That's all for today. We have discussed the problem and the solution. I hope you guys enjoyed the problem. For more such problems, you can practice Putnam past papers problems, you can practice IMC problems, Simon Marais problems, etc. You can also check the website link. I also have a website named Solve Problem with Samprit. You can check the fractions website. And that's all. Happy problem solving. So thank you for watching the video.